AP Calculus AB first 6 weeks test. We had a test the other day on the first 6 weeks. Problem number 1, what is f prime of x if f of x equals 5x squared plus 2x minus 3? This is quite an easy problem. To do this, we're going to use the power rule. F prime of x equals, we take 2 times 5, which is 10, and we have x to the 2 minus 1 power, which is going to be x to the first power, plus 2x. Well, what happens, we multiply 1 times 2, so we're going to have 2, and we have x to the 0 power, which is just 1, and then the derivative of a constant is 0. So we're starting out with a real easy problem. A lot of tests start this way. Problem number 2, what is the average rate of change of the function f of x equals 2x squared over the interval from 1 to 3? Well, the average rate of change, we use what we call a version of the slope formula, which we're going to say average rate of change as an acronym equals f of b, which is the y value, minus f of a, which is another y or output value, over b minus a. So it's the same as y2 minus y1 over x2 minus x1. And we're going to label our values on the interval. 1 is a and 3 is b. And so we need to find f of b. And to find f of b, we just plug in 3, which equals 2 times 3 squared, which is 2 times 9, which is 18. And for f of a, that's going to be f of 1, which is going to be 2 times 1 squared, which is 2. So f of b is 18 minus f of a, which is 2, over b, which is 3, minus a, which is 1, and we get 16 over 2, which equals 8. Make sure you box in your answers to communicate to the test grader that what your answer is without having to hunt around for it. Okay, 3, find the limit as x approaches 3 from the negative side of x plus 3 over x minus 3 if it exists. If the limit is infinite, determine if positive infinity or negative infinity. Well, to plug in 3, if we just plug in 3, we're going to get the 3 plus 3 over 3 minus 3, which equals 6 over 0, which is going to be infinite. So our answer is the limit. So the limit does not exist. And then further, if the limit is infinite, which it is, determine if positive infinity or negative infinity. Well, to do that, what we're going to do, since we're coming from the left side, we take a value of less than 3. And a value of less than 3 would be 2. So if we take x, we let x equals 2, we'll have 2 plus 3 in the numerator and 2 minus 3 in the denominator, which is going to be equal to 5 over negative 1. And that is negative. And so since that value is negative, we would be coming from the negative side, which would be negative infinity. So 2 parts to this answer, half credit for each. Problem 4, what is the limit as x approaches 2 of x squared plus x minus 6 over x minus 2 if it exists? Well, what we're going to do is we're going to plug in the limit as x approaches. Well, we're just going to plug in. We're just going to say 2 squared plus 2 minus 6 in the numerator and 2 minus 2 in the denominator. So the numerator 2 squared is 4, plus 2 is 6, minus 6, we have 0 over 0. As my students know, that means more work is needed. So what we do is we try to factor. So this is going to be equal to the limit as x approaches 2 of, we have x minus 2 in the denominator, and in order for this thing to work out, we're going to have to be able to cancel that x minus 2 in the denominator, and so one of the factors we surmise in the numerator is going to be x minus 2. And what times x minus 2 equals x squared plus x minus 6? Well, that's going to be x plus 3. And so we remove that discontinuity here, so we have the limit as x approaches 2 of x plus 3. And replacing x with 2, we have 2 plus 3, which equals 5, which we box in as our correct answer to problem 4. Okay, problem 5. I had students have a problem with this one. Shouldn't have been that much of a problem. The function g is continuous on a closed interval from 3 to 5. The function has values given in the table above. The equation g of x equals 5 must have at least 2 solutions in the interval, closed interval from 3 to 5, if k equals. Let's make a drawing of what this thing looks like. Okay, we have an xy coordinate plane. We have an input value of 3 over here on the left, 5 over here on the right, closed interval. And for input value of 3, input value of 3, we have an output value of 1, which I mark in blue. Input value of 5, we have an output value of 2. So what is being asked here? It's being asked if we want to have a solution at 5, which I'm going to take at 5 horizontally, this horizontal dotted line, we're going to have a value of k where for input of 4, right, an output of k where this thing, the function has to cross. Okay, the function is continuous, that's defined. Function continuous, so the function is going to have to cross this value of 5 and cross it again, which is the only value that requires 2 crossings of that value of 5. It's going to be this one, e, because if we're up here at 6, if k is 6 up here, then the function is going to have to, at some point, cross 5, and then eventually cross 5 again. So a little schematic could have really helped with this one. Problem number 6. If f of x equals 2x squared plus x plus 1 over x, then f prime of negative 1 equals. Well, we can rewrite f of x in what I call calculus-friendly form as 2x squared plus x plus x to what power? Well, x to the negative 1 power. And then f prime of x is equal to 4x, and the derivative of x is 1 plus 1, plus we have this negative 1, x to the, and negative 1 minus 1 is negative 2. So f prime of x is going to be 4x plus 1 minus 1 over x squared. And so f prime of negative 1 is going to be 4 times negative 1 plus 1 minus 1 over negative 1 there we go, negative 1 squared. And this is going to be equal to negative 4 plus 1 minus 1, which equals negative 4, which we box in as our correct answer. Okay, that's the first page of the test. Next on the second page, use this piecewise function for questions 7 through 10. And we have let f of x equals x squared minus 2 when x is less than or equal to 1, and negative 1/2 x plus 1 when x is greater than 1. And so the first one we have here is find the limit x approaches 1 from the plus side of f of x equals, well, we're just going to plug in 1 here. So we're going to have negative 1/2 times 1 plus 1, which equals negative 1/2 plus 1, which equals 1/2. So that would be our answer to problem 7. Okay, problem 8. The limit as x approaches 1 of f of x equals, well, the limit as x approaches 1 from the left side of f of x equals the limit as x approaches 1 from the right side of f of x. And we've already figured out the limit from the right side. That's going to be this from the plus here. So we have 1/2 on the right side. And the left, we're going to substitute in 1 for this thing here. So we're going to have x squared, which is 1 squared, minus 2, which is going to be 1 minus 2, which is negative 1 equals 1/2. Okay, so our conclusion is since limit as x approaches 1 from the left side of f of x does not equal limit as x approaches 1 from the right side of f of x, then limit as x approaches 1 of f of x does not exist. Okay, so that's math notation. That's 8. 9, f of 1 is, well, we already figured out f of 1 equals, we have this left side from the left because x squared minus 2 when x is less than or equal to 1. So that's when also when x is equal to 1. So f of 1 is going to be from the left side negative 1. And then we'll box that in. And then 10 is f of x continuous at x equals 1. Justify your answer analytically with math notation. Okay, for continuity, condition 1 exists, but condition 2 does not. So we say since the limit as x approaches 1 of f of x does not exist, f of x is not continuous at x equals 1. So we'll box this in as a correct answer also. Okay, next problem, 11. Assume that limit as x approaches b of f of x equals 7 and limit as x approaches b of g of x equals negative 1. Find the value of limit as x approaches b of f of x minus 3 g of x. Well, that's going to be equal to, we're given what the limit of f of x is 7. And we have minus 3 times the limit of g of x, which is minus 3, times negative 1. And so we're going to have 7, and then negative 3 times negative 1, that's going to be positive 3. So our answer is going to be 10. Okay, that's all there is. That should have been a pretty easy one. Problem number 12. Evaluate the limit as x approaches 1 of f of x minus f of 1 over x minus 1 when f of x equals 2x cubed plus 4x plus 1. Well, for this, we're going to rewrite this as the limit as x approaches 1 of, we're just going to write out f of x, which is 2x cubed plus 4x plus 1, and then x minus 1 minus f of 1. So we got to find f of 1. So we plug in 1, f of 1 equals 2 times 1 cubed plus 4 times 1 plus 1. Well, that's going to be 2 plus 4 plus 1, which will equal 7. So now we're going to have to subtract f of 1, which is 7. And so if we plug in 1, okay, if we plug in 1, we're going to get 2 times 1 cubed plus 4 times 1 plus 1 minus 7 over x minus 1. So that's going to be in the denominator 1 minus 1. So we have 7 minus 7. We're going to get 0 over 0. So we're going to need to factor that numerator. And we have a cubic relation here to factor, which isn't going to be as easy as a quadratic. But we're going to have this x minus 1 here. What if we're going to have remaining in the numerator here, we're going to have 2x cubed plus 4x, and we're going to have minus 6. Okay, so let's go ahead and divide this by x minus 1. This is a cubic polynomial. Well, for doing that, what I'm going to do is use synthetic division. You might remember that back from pre-calculus. We're going to put the 0 for this denominator, so we put 1 on the outside. So we have 2x cubed plus 0x squared plus 4x minus 6. So we bring down the 2, we get 2x squared, 2 times 1 times 2 is 2. We get 2. 1 times 2 is 2 here. 4 plus 2 is 6. 1 plus 6 is, 1 times 6 is 6. We get a remainder of 0. So we're going to get 2x squared plus 2x plus 6 after factoring out our x minus 1, since we divided by x minus 1. So that's going to be equal to the limit as x approaches 1 of x minus 1, and we have x minus 1 still in the denominator, and we have 2x squared plus 2x plus 6. And we have a cancellation, and if we substitute in 1 for everything else, we have 1 in place of x, we have 2 times 1 squared plus 2 times 1, oops, 2 times 1 plus 6, which equals 2 plus 2 is 6, which equals 10. Okay, to me, the factoring out was the toughest part of this. Now, this is maybe the most challenging problem on the test. Problem 13, find the vertical asymptotes of f of x equals x minus 3 over 2x plus 1. Well, what we have to do is, if we don't have a cancellation, which would be a removable discontinuity, we don't see that these can be canceled by factoring. So what we need to do for our vertical asymptote, we need to set our denominator equal to 0. So we put 2x plus 1 equals 0, and solving, we have 2x equals negative 1, so x equals negative 1/2, and that is the equation of our vertical asymptote, which we box in as our correct answer. Okay, we skipped here 14, let's see, yeah, 14, 15. Okay, the limit as t approaches infinity, 3t minus 5t squared minus t cubed over 7t cubed plus 2t minus 1. So essentially for this, when it says bottom equals top, use coefficients. And so we're going to have in the numerator, our highest exponent here is 3. And that's the same for the numerator and the denominator. So our coefficients are going to be negative 1t cubed over 7t cubed. So our answer for number 16 is going to be negative 1/7. Okay, problem 17. What happens is, this is a situation where we have a limit as t approaches infinity of t squared over 2 to the power of t. What happens is a polynomial function, which is on the top, t squared, is smaller than an exponential function on the bottom. So we're going to, as we go toward infinity, the one on top is going to grow, but at a much slower rate than the one on the bottom. And so that's going to end up being a value of 0. And so we would say also a horizontal asymptote, not that it's asking for that, is y equals 0. And likewise on 16, the horizontal asymptote would have been y equals negative 1/7. Okay, let's see. Number 18. Use the table below to determine the limit as x approaches 3 of f of x. Well, we're getting closer and closer as we go from the left. I'm going to draw this arrow in red. We're going right here. Okay, we're getting closer and closer. And we're getting closer to 3 from the left side. And on the bottom, we're getting 29.987, 29.992. And from the right side, we're going down 30. So it looks like that if we look for a good number for that, we'd have to say our best guess would be that our limit would be 30 from the left and the right side, which happen to equal each other, so the limit would exist and therefore be 30. That's the best estimate we have. Next, 19. Given f of x equals x cubed minus 2x plus 5 over the interval 0 to 2, which of the following values is guaranteed by the intermediate value theorem? Well, this is kind of going back to our problem 4 in a way, isn't it? So we have a function here, and it's a cubic function, so we know it's going to have that squiggly shape, but we're not going to concentrate on the value so much. But we know we have an input value of 0 we're going to take a look at, input value of 2. So we're going to go ahead and plug in 0. If we say f of 0 is going to be, well, it's going to be just 5. So at 5, we're going to have an output value. And then f of 2 is going to be equal to, well, we have 2 cubed minus 2 times 2 plus 5, which we're going to get 8. 2 cubed is 8, minus 4 plus 5. So 8 minus 4 is 4 plus 5 equals 9. So at 9, we're going to get an output value. Okay, to get a value guaranteed by the intermediate value theorem, we have to be somewhere between this 9 and this 5, which is the only value that is in between. It's going to be this value of 7. So this value of 7, we don't know exactly where it is. I don't know what this equation looks like. We could plug in something to find where the output is 7 somehow. But this value of 7 is going to have to be crossed at some point. So our correct answer is C, like problem 4, an intermediate value theorem problem. 20, determine the value of k that makes the function continuous. Show your work. Well, I think a lot of you guys did pretty well on this one. We'll say the limit as x approaches 5 from the left of f of x equals the limit as x approaches 5 from the right side of f of x. And then the value from the right side is the f is defined, happens to this greater than or equal to. So if we just set these two limits equal to each other, if we solve for k, we should have the thing. So if we plug in 5, we're going to get on the left side 5 squared minus k equals, on the right side we have 4 times 5 plus 2k. And then so we're going to have 25 minus k equals 20 plus 2k. And then we have, if we add k to both sides of this equation and subtract 20 from both sides of this equation, we have 20 minus 20 cancel on the right side, negative x plus x cancel. So we're going to get 5 equals 3k. In solving for k, we have k is equal to 5/3. And a lot of you got this right. I think I gave you, since it took a little work out, I think I gave you a couple points for this one too. Shouldn't have been that hard. Next, problem number 21. Determine if g of x is continuous. Justify your answer analytically with math notation. Well, step 1, okay, 1, we have g of negative 7 exists and is equal to negative 7. Excuse me. Actually, we want g of 0, don't we? Yeah, that's negative 7 exists. N equals 0. That's right. And is equal to 0 because when x is negative 7, our value of our function is 0. 2. Okay, we want to find the limit exists. Well, if we take this x squared minus 49 over x plus 7, we can rewrite this as difference of squares. We have x plus 7 times x minus 7, and so we have over x plus 7, and so we have cancellation, so we have x minus 7. And plugging in, if we plug in negative 7, right, we have negative 7 minus 7, which equals negative 14. So we say the limit as x approaches negative 7 of g of x equals negative 14. Now condition 3 is since g of negative 7 is not equal to the limit as x approaches negative 7 of g of x g of x is not continuous at x equals -7. So 1, 2, 3. So we follow the steps here. And I'll just go ahead and box in the conclusion. Next problem, 22. The graph of f of x shown above. The graph passes through the points 0, 2 and -2, 0. Which of the following statements are true? Well, the limit as x approaches -1 of f of x does not exist. Well, that's a false statement because the limit does exist. The limit does exist and equals 1. Statement 2, f of -1 does not exist. Well, that's true, right? Because if we plug in -1, we get a hole. So that is true. I'm going to put a check mark instead of an X. And finally, the limit, the f of -1 equals the limit. Well, we do have a limit, but f of -1 does not exist, so that is not true. Our only item that exists is this Roman numeral 2 only. So we circle in answer B. 23, determine the horizontal asymptotes for the following function. Basically, we're interested in the highest powered thing in the numerator and denominator. Basically, we have in the numerator this square root of 9x to the 4th power, and in the denominator we have this 2x squared. Well, if we take the square root of 9x to the 4th power, we're going to get 3x squared, right? Because the square root of 9x to the 4th is going to be equal to 3x squared. So we're going to be left with 3x squared over 2x squared, and that's going to be a bottom equals top use coefficients. So our answer for this one is going to be 3/2. So we'd say the horizontal asymptote is y equals 3/2. I'd like you to play around with your calculator on that if you like. Okay. Next problem, 24. Use the definition to determine f prime of x when f of x equals x minus 3x squared. Now, we went over this quite a bit before the test. I don't know what the trouble was. So the definition derivative is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. And for this, what we're going to do is plug in f of x in the numerator. Anywhere there's an x, we're going to put plus h. So we have x plus h. That's in place of this first x minus 3 times x plus h squared. And then we're going to have minus f of x, which is going to be minus, I'll just put parentheses here, x minus 3x squared. And then we have h. And so that's going to be, we'll put limit as h approaches 0. And then we're just going to go ahead and simplify out. Okay, equals a limit as h approaches, h equals, h approaches 0, h equals 0. We have in the numerator x plus h and minus 3, and we multiply out the inside, we're going to get 3x squared plus 2xh plus h squared, and then we're going to have minus x plus, because minus minus plus 3x squared all over h. And so that equals the limit as h approaches 0 of, we have x plus h minus 3x squared, and then minus negative 3 times 2xh is going to be negative 6xh, and then minus 3 times h squared is going to be minus 3h squared, minus x plus 3x squared all over h. And what cancels? Well, the negative 3x squared and positive 3x squared cancel, and this x and minus x cancel. So we bring down, we have left here, we have limit as h approaches 0 of, we simply have h and then minus 6xh, and then we have minus 3h squared all over h, which equals the limit as x approaches h of, we factor out an h, we have 1 minus 6x minus 3h over h. And so h over h cancel. So what we have left is the limit as x approaches h of 1 minus 6x minus 3h, which equals 1 minus 6x, which should be our answer. But we can also check up here, if we take, using the power rule, f prime of x is going to be equal to, the derivative of x is going to be 1, and then minus 2 times 3, 6x. So we had the ability to check. And so we used the definite derivative and came up with this 1 minus 6x. Next problem, for problems 25 and 26, f of x equals 2x minus 3 and g of x equals x plus 1. So we can do this thing different ways. We can just multiply these out. But I'm just going to use, in this case, like a uv for a uv prime plus vu prime, right? That's going to be a product rule. And that's going to be, if you want to have the derivative of the product of two functions, we have u and v, we have u v prime plus v u prime. So in this case, we have, if we let that, say u is equal to 2x minus 3, and u prime is equal to 2, v is equal to x plus 1, and v prime is equal to 1. So r prime of x is going to be equal to u, which is 2x minus 3, v prime, which is 1, plus v, which is x plus 1, u prime is 2. So r prime of x equals 2x minus 3 plus x plus 2, which equals, let's see, 3x, and that's going to be negative 3 plus 1, that's going to be minus 1. So r prime of, in this case, we're asked for 3, right? 3 is equal to 3 times 3 minus 1, which equals 8. Let's see if that's what I got earlier. I'm pretty sure it was. Should have got 4. Did I get that plus 2. Well, this should be 2x here. Plus 2x. So we're going to get 4x minus 1. So it's going to get 4 times 3 minus 1, which equals 11. Okay, 26. If q prime equals f of x over g of x, find q prime of x. Well, this is a low, d high, quotient rule. Low equals, well, g of x is going to be x plus 1, and d low is going to be 1. High is going to be equal to 2x plus 2x minus 3. And d high is equal to 2. So q prime of x is going to be equal to low, which is x plus 1, d high, which is 2, minus high, 2x minus 3, d low, which is 1, over low squared, which is going to be x plus 1 squared, and which equals 2x plus 2 minus 2x and that's going to be minus minus plus 3. So we have x plus 1 quantity squared, and 2x minus 2x cancel each other. So we're going to have 5 over quantity x plus 1 squared, and q prime of 2 is going to be equal to 5 over 2 plus 1 squared, which is going to be 5/9. That will be our slope of that expression. Next problem. 27. What is the equation of the line tangent to the graph of f of x equals 2x squared minus 3x where x equals 4? That's going to be, or we need a point and slope. If we have those two things, then we can use the point slope form y equals, y minus y1 equals m times x minus x1. So we already have our x value for a point. We need f of 4, which equals 2 times 4 squared minus 3 times 4. And 2 times 4 squared is going to be 32 minus 12. That's going to be equal to 20. So our point is going to be this one, the point 4, comma 20. Okay, next we need to find our slope. So for that, we're going to take f prime of x, or find f prime of x, which is 2 times 2, we get 4x, and then minus 3. So our slope is going to be f prime of 4 is going to be 4 times 4 minus 3, which equals 16 minus 3, which equals 13. So our line is going to be y minus y sub 1, which is 20, equals 13, x minus x sub 1, which is 4. And that's all we need. That's point slope form. We could add 20 and get this thing in slope intercept form. I think it's going to be 4 times 13 is 52%. Anyway, that'll be negative 52. Anyway, I think it's going to be 13x minus 32. Next, for the equation y equals 1/2 square root of x, find y prime. we're going to do a rewrite for this. So we'll rewrite this as y equals 1/2 x to the 1/2 power. So y prime is going to be equal to 1/2, that's 1/2 out front, times this 1/2 already, times x to the negative 1/2 power. 1/2 minus 1 is negative 1/2. So y prime is going to be equal to 1/4 square root 1/4 square root of x. And that would be it. Next problem, 29. The table below shows the population of small town at different years between 2000 and 2021. What is your best estimate of the rate of population growth in the year 2007? Please indicate the proper units. Well, we're looking at an average rate of change, really. So A rock equals f of b minus f of a over b minus a. In this case, we're going to use for 2007, we're going to use our b over here at 2011 and our a over here at 2004. So what we have is f of b is 25 minus f of a, which is 20, over 2011 minus 2004 is 7. So we're going to get 5/7. And units is going to be people, we'll say population growth per year. And I think I saw 5/7 of a person per year. I saw some equivalent description. So that's going to be that one right there. And then next, what is 2 times the integral from 0 to 4 of x minus 2 dx? Well, for that, if we go ahead and draw this out, we have the equation x minus 2, y equals x minus 2. What that's going to be is, that's a y-intercept of -2 and a slope of 1. So our function is going to go up like this, cross our 0 and go up like this. And here is 3, 4. And so we go up here to 4 and down. And between 0 and 4, we have this top area subtracting the bottom area. And what we have is we have 2 triangles whose areas cancel each other. So our answer is going to be 2 times 0, which equals 0. Okay, a sketch, to make a little sketch of that shouldn't be too bad. Last problem, what is the intersection of y equals 4 and x equals 3? That should be pretty easy. If we have an equation here, y equals 4, we have another equation of y equals 4, and we have another equation, x equals 3. Where do these things intersect? Well, it's going to be simply at the point 3, 4, and what I was looking for simply was not a sketch, but just a boxed in coordinate pair of 3, 4. Anyway, good luck in your corrections and continuing studies. Use this to help you get to the next level. Thanks for viewing.